5 minus 3x. 5 minus 3x kind of looks like 3x minus 5, but they're not the same. They're off by a sign. Like the 5 is positive, it's negative over here on the left, negative 3x, positive 3x. So how can you change that? Well, you can actually factor out a negative. So I put that there. It becomes 3x minus 5. Basically, you switch the signs here. All right. If you feel like, even if you don't fully understand it, hopefully you can see the progression here of this problem. We've just been working on the two bottoms. Now on the left here, we're just going to put this back in on the bottom. But on the right, we're going to combine this and this. We're going to combine them to make a plus. All right. So this is going to become 3x plus 5 over 3x minus 5. 3x plus 5 plus 15x over 5x 3x minus 5. Yeah, just same tops, different bottoms now. Is that okay? Is that clear?
Yeah.
All right. Okay. So now this is somewhat similar to what we did last week. Do you see any cancellations? But this time you can only look sort of like just over here in this box and just over here on the box on the right separately. So let's just focus on the one on the left.
3x plus 5.
Okay, and what's remaining on the top when you cancel these? There's something here.
Yeah, 1.
1. So this becomes 1 over 3x minus 5 plus, do you see any cancellations over here on the right?
5x and 15x maybe?
Yeah, you got it. So 5x and 15x. Now that 15 reduces to what? What is 15 divided by 5?
3.
3. So this becomes on the right 3 over 3x minus 5. What do you notice about the bottoms?
They're the same.
They're the same. They're really important. Because they're the same, you can combine the tops. So you keep the bottom, you write one bottom, but in this case, you add the top plus top. Now this one worked out really nicely after the cancellations. They don't typically work out that nicely, but I'm glad the first one did. Kind of, nice, get settled here in this. Anything you'd like me to clarify from this problem or?
No.
Okay. Now you said you did 26 already. Is that right?
Yeah, I already got 26.
Nice.
But honestly, I don't know if I finished it when I'm looking back at it.
Well, let's take some time now and work on it together.
Yeah, so I think I still have work to do probably. I mean, we'll see. I mean, I have most of it though, for sure.
Good. I appreciate you trying out some problems before our lesson. Gets you, ready, warm up kind of thing. So you do try to factor everything to start. And like I mentioned before, I'm gonna do this for you because I don't want us to be spending lots and lots of time on that here. I do cross out the ones that we're factoring: x minus 7, x plus 6, like that. Okay, now I'm going to rewrite. So this becomes x minus 6 over x times x plus 6 plus x minus 7, x plus 7, x minus 7, x plus 6. All right, now do you see any cancellations?
Yeah.
What do you see?
X minus 7 on the right side.
Okay, anything else?
Uh, I don't think so.
There's nothing else. The only reason I added parentheses around this is I wanted you to see that it's really like together.
Mhm.
It's not like there's a lingering X here.
Oh,
They're in parentheses, so the whole thing would have to cancel. Okay. So it is worth rewriting this yet again. It's sort of, comical how much rewriting I have to do here. But it is necessary. All right. Are the bottoms the same?
Mm, yes.
Exactly the same.
I mean, the left one has the visible X, but yeah.
So I feel like we're really good at this as humans. Like we like see someone else or we have a friend. It's like they've got that, but I don't. Or whatever scenario you want to think of. The one on the right here is missing an X. You ever put together a puzzle and there's a piece missing, and that's pretty frustrating.
Yeah.
Same with really anything. You're like, you the one on the right here is missing an X. Okay,
Oh, okay.
and you have to see that. You have to see, okay, it's missing an X. Now you can't just write an X, okay? I mean, as nice as that would be, you can't just write it. In fact, let me put it over here on the left here. It would be nice if you could, but what you can do is you can multiply the top and the bottom by the same thing. The reason is because anything divided by itself is 1. So like the net result is no change. Okay, but in terms of this problem, what it does is it gets the bottoms to be the same. But I did change the top. I'm going to take your silence as maybe not liking that. And so I'd like to provide you an example with another example here. But you tell me, does this bother you? Feel wrong?
Uh, Man, yeah, kind of, but
All right. So
math
like,
already feels pretty weird to me, so I mean, I'm not really that surprised.
well, there's help. It's better to have some understanding. It's like, well, why does this even work? So do you have a favorite fraction by chance? 1/3, 1/2, 1/6,
Uh,
1/8, 2/3.
I hate fractions, but
It's pretty strong.
yeah, I don't know. It's because my teacher forced us to always make them fractions, but I used to always do decimals. But um, I mean, 1/2, I guess you can't get more simpler than that, really.
I like it. Are you a glass half full or half empty guy when you're
I mean, full, I guess.
half full? I like it. Okay. Let's say we multiply the top and bottom by, I don't know, 7. Some people think 7 is lucky. I don't really understand that, but it is a number. Top is 7, the bottom is 14. If you go to your calculator and type in 7/14, you get 0.5. Just like over here, you get 0.5. So have you changed it?
Um, Not technically. I mean, they're kind of the same thing, as look different.
Right. So in the math world, we would say that they are not different. It's like the net change is no different.
Yeah.
Okay. And this is not a proof. This is just a simple numerical example of saying if we multiply the top and bottom by the same thing, it does not change the outcome.
Mm-hmm.
Okay. And that's like as far as I want to go in terms of like getting you to, believe or buy into this. But if we go back to our problem here, by multiplying the top and bottom by X, there's no net change.
Okay.
All right, so we do have to just go with it for now. Since the bottoms are the same, you keep the bottom, but the top here you do combine. So it's plus X times X plus 7 like this. Is that okay?
Yeah.
All right. Now in the numerator, we can distribute this x to both terms. X times x, x times 7. Can you tell me what that becomes?
X squared
Good. Plus.
and plus 7x.
Cool. And they've got x minus 6 here, plus over x times x plus 6. All right. So last step here is to combine like terms in the numerator. So anything that's the same. So there's a 1x over here, there's a 7x there, that's 8x. X squared goes out in front by preference. Something like this. Is that okay?
Yeah.
All right. Now you look and you see, well, can I factor this? Like is x squared plus 8x minus 6 completely done? And it is, but you may not know it, or you may not be sure. A lot of times you cannot factor these. So, this is our final answer here.
Okay. All right. I had most of that. It was one step off.
Oh, good. Let me know if you need some more time here to get this written down.
All right, now I'm good.
All right. So let's take a look at number 28. Okay. So we're doing pretty good in terms of time here relative to getting through all of these. Let's just talk a little bit about factoring. We'll look at the one on the right here first. Do you remember this type of factoring? Does anything about this type of factoring stand out to you on the right?
Not really.
Okay, so notice there's a 1 in front of the x squared, or the a squared in this case. That's really good, really important. The number on the right is 21. Can you think of two numbers that multiply to 21? I'll take any of them.
73. 3 times 7.
Okay, good. 1 and 21 and 3 times 7. Do either of these add up to -10?
Oh, this step. I mean, -3 and -7 would, but
Now, good response here. Does -3 times -7 multiply to +21?
I think so for
Yes.
multiplication. Yeah.
Yep, two negatives go to a positive. So this becomes a minus 3, a minus 7, like that. Good, really good. All right, so we're going to look at the other one here. I'm just going to bring it down. A squared minus 5a minus 14. This time you're looking for two numbers that multiply to -14. Has to be negative. That means one's going to be positive and one's going to be negative.
Wait, two numbers that add up to -14.
Multiply to -14.
Oh, negative. Wait,
I'll take anything, but you can.
-7 and 2.
Okay, and then it's also true that it's the other way around, 7 and -2.
Yeah.
But do either of these add up to -5?
Yeah, -7 and 2.
So it becomes a minus 7, a plus 2. Is that okay?
Okay.
So here's what we've done. We've taken the original problem, and I had been helping out here with your factoring, but you just did the factoring for this one. Okay. And do you see now that the bottoms are different? They're the factored form.
Yeah.
All right, good. So let me write this a little cleaner here. Oh, how do I want to do this? I guess I can copy and paste. Sometimes there's too many options to do everything. Plus 5 over this. Okay. Are the bottoms the same?
Yeah, no.
No, they're not. They share. What do they share? That's
A
another thing.
-7.
They share an A-7. So that's good. Okay. But the one on the right has an A-3. The one on the left has an A+2. So to kind of balance this out, what we're going to do here is we're going to give the one that's missing something. We're going to multiply the one that's missing something. So on the left here, this one on the left is missing an A-3. Do you see that?
Yeah.
So now if I multiply the top and bottom by A-3, is there any net change? Meaning, like, is it the same on the top and the bottom here? Like, does this cancel out?
No.
They're the same though. They're the same things cancel out. So that's why this is okay. That's why you can multiply the top and bottom by the same thing, because it's no net change. Like, that it's effectively the same.
Okay.
On the right here, we're missing, what are we missing on the right? What does the left have that the right does not have?
A+2.
So you're going to put an A+2 on the bottom and an A+2 on the top. Actually, I probably should just rewrite this one more time here. A lot of rewriting. Okay, do you agree that the denominators are the same now? The bottoms are the same?
Yes.
The order doesn't matter, but they are the same. And that's what's important here is that they're the same. Since they're the same, you can keep the bottom, right? When you add something, if you keep the bottom here, but you add the top or subtract the top, depending on the problem. So it's gonna be A times A-3 plus 5 times A+2, like that. So we just merge the top.
All right.
I know it's a lot of writing. I know it's like very, taxing just to see all this stuff, but like, can you see how I went from this top to this bottom? You just move the tops together, keep the bottom.
Yeah.
All right. Now in the tops, we're going to multiply the A times the 2 inside and the 5 times the 2 inside. So what is A times A?
A².
Okay, and times 3? Minus 3?
5. 3. -3.
Yes. And then on the right here, when you take this 5 on the outside, multiply in, what does that become?
5A + 10.
Good. And the bottom stays the same. And I've got the benefit here of copy and paste. And then moving this. So we're really good here. The numerator, you can combine the minus 3a and the 5a. What does that become?
2, I don't know,
2a. Yep.
yeah, 2a.
And then we've got the bottom here again. Same. So you always check, maybe you can factor the numerator. In this case, you cannot. I know I'm just telling you that, but that is something you would think about. You would think, well, you know, can I combine this or not? So we are done with this problem here.
Okay. All right.
Any questions on that before we move on to a new problem?
No.
All right. We're up to 30 now. 30 is really similar to number 28. It's a lot of the same steps here. And so you can see, like we've we're at almost half hour here. We've done 1, 2, 3 problems. These take a while. These are not meant to be done.
They do.
Yeah. So keep in mind, it's not like you're going to get 10 of these on a test. You're going to get a couple that you got to be able to work through. So let's focus on the factoring here. We'll start with the one on the left here, x squared minus 5x minus 36. So you're looking for two numbers that multiply to minus 36, but they have to add to minus 5. So one's positive and one's negative. What do you see here? What stands out to you here?
I have no idea.
Okay. Are you allowed to use a calculator? I can't remember if you said you are or not.
Yeah.
Okay. So what I would recommend is you grab your calculator and you sit there and you're like, all right, what's 36 divided by 1? What's 36 divided by 2? What's 36 divided by 3? And you keep going until you find two numbers that get you to minus 5. Do you understand what I mean by that, or do you want me to show you?
Yeah, I think I get it.
Okay. Because we know 1 and 36 work, but it's way too far apart. Not going to get you to minus 5.
I mean, closest I could really get to -5 on dividing 36 is like dividing it by -9, but I don't know how to get it to 5.
So like 2 and 18 work, 3 and 12 work, 4 and 9 work, right? Like 36 divided by 4 is 9.
Negative. So it's 9 and 4, but it'll be -9 and +4.
Good. Yep. X minus 9, X plus 4. Very good. So we're going to do the same thing now for the other one, X squared minus 7X minus 18. So for two numbers that multiply to minus 18, but add to -7.
2 and wait, what is that? 2 and 9. The -9, +2.
Good. So x minus 9, x plus 2. Do you notice that the sequence of events here is the same as what we did in the previous problem?
Yeah.
I don't know if you like cooking or baking, but there's a recipe here. There's a set of steps. If you follow them, you know, you should get the same result every time. All right, so our original problem, which is up here, we factored the two bottoms, and I've just rewritten it down here for you. So just like in the last problem, what am I going to ask you here about the bottoms?
If any are the same.
Are they the same? Yeah.
I mean,
Or what's
just like
different
last-
about them?
I mean, there's x in x minus 9 again, which is
Yep.
the same, but x plus 4 and x plus 2 aren't.
So it's just like the last problem where you decide, well, what's missing? You know, what does one have that the other doesn't have? And on the left
yeah.
here, what's missing? Sorry.
X plus 2 for left and x plus 4 on the right one. I mean,
So we're going to multiply the top and bottom here on the left by the x plus 2, by the one that it's missing. You can think of the blue as what's missing.
and wait, x squared.
We're just going to rewrite it here. But is that clear though, that we just multiply the top and bottom by the one that's missing, which is x plus 2?
Yeah.
And then on the right here, it's missing an x plus 4. We'll put that on the top and the bottom.
Okay.
So now just again, a lot of rewriting here, but I'll just put it out here. For x times x plus 2 over x minus 9, x plus 4, x plus 2 plus 12 times x plus 4 over x minus 9, x plus 2, x plus 4. Just rewriting it. I'm not, no math, just more, you know, like a scribe, basically. Any questions on that?
No.
All right, so now since the bottoms are the same, what can we do to the top?
Merge them. Merge them.
Yep. Yep. In this case, merging them means we're going to add the tops. But there's nothing to add quite yet because you have to be able to, they have to be like terms. So you just write it like this, and then we will distribute. Yeah, but again, ton of writing. I don't think they do enough to warn you in the classroom about this, but nevertheless, that's what's in front of you. All right, what is 4x times x plus 2?
4x squared and 8x.
8x, good. And on the right here, taking that 12 and you're multiplying in.
12x and what is that? 48.
48. Bottom is still the same. What can we combine in the top? Excuse me.
8x and 12x.
Yeah, so 4x squared plus 20x plus 48. Excuse me. All right, and just to be sure here, we should factor the numerator as much as we can to see if there's any other further simplifications. There's a GCF, greatest common factor of 4 in the numerator. So that's x squared plus 5x plus 12. But the nice thing is that this does not factor. It typically doesn't. Like I want to tell you, like, oh, you don't ever have to worry about it not factoring, but at some point it will. Then you'll, wish you had looked at it. But 80% of the time it won't. Is that okay?
Yeah.
All right. So as much as like, I'm sure you probably want to do 32 here. 32 is like weird, it's symbolic. It's not going to be good for you in terms of your learning. I'd like to do a different problem with you, but if you say like, hey, Matthew, I got to do 32 because it's part of my assignment, I got to make sure I get it, we can do 32. I just think that it's not going to be in your best interest for us to do it today. You tell me though, what would you like to do?
No, that's fine. We don't have to do that one today. I can just do it some other time or whatever.
Okay. So I'd like to pick some other problems on this page for us to look at, or if you, Mom, or you can quickly send us over something else you'd like us to do, be happy to do that.
No, you can just pick another one. I mean, I don't have any other problems that I need to do. So
All right. Let's look at 20. Did you already do 23? Is that why it's circled, or is that just
no.
okay? All right, so I'm going to do 23, kind of going back because the difficulty here is not as high. Okay. 2x minus 6, x squared minus 36, x squared plus x minus 12, x squared minus 2x minus 24. Is there something here, one of these four, that you think you can factor on your own?
Are we still doing just it has to stay on one side?
Yeah. Like I'm asking you to look at this top left, bottom left, top right, bottom right. Do any of those like individually stand out as like, yeah, I think I can factor those?
X squared and x in the bottom left.
Okay. So why don't you go off to the side here, figure out the two numbers that multiply to minus 12 that add up to positive 1, and tell me what goes in parentheses here, please.
Um, 4 and -3.
So what goes in parentheses?
X plus 4 and x minus 3.
Very good. All right, so that's one down. What I typically do is write it like underneath and then cross it out, or above and cross it out. The one in the top left here, a 2 goes into both of them. So it's 2 times x minus 3. So the next one I want you to look at now is the one on the lower right, x squared minus 2x minus 24. Two numbers that multiply to minus 24, but add to -2. A little bit tougher, but you can do it. So this is where you need to grab your calculator and go 24 divided by 1, 24 divided by 2, divided by 3, divided by 4, 5, 6, whatever you need to do. If it doesn't work out evenly, you skip it, but it works for most of those numbers I just mentioned.
Yeah, I have no idea.
Okay. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then one has to be positive, one has to be negative.
4 and 6.
So which one's positive, which one's negative?
Negative 6 and positive 4.
Good. X plus 4, x minus 6. Okay, so that takes care of this one on the lower right. This one in the top right, x squared minus 36. I'm sure you've seen it. Do you, it doesn't matter what I don't care if you remember what it's called, but do you remember how to factor it? Do you remember it's called a special product, but any idea how that works out?
Factoring?
Yes.
Wait, which one am I factoring?
The x squared minus 36. Notice it's different than the others. Like it doesn't have the middle x or 2x. It's just got two terms.
Mm,
So let's look at it a little bit differently. Are there two numbers that multiply to 36 but add to 0?
I mean, it would have to be. Wait,
But keep in mind, one has to be
Ah.
positive, one has to be negative.
yeah, 6 and 6 is 1 negative, 1 positive.
Yes, and that's why this is considered a special product, because one is positive, one is negative. It's the same number. Right. So just the factoring is a chore. Like it really is. Like don't discount that. Like there really is a lot of effort that goes into being able to factor this. So we're gonna take this original one here. We're gonna rewrite it and see what happens here. So I'm just gonna clear the screen. It's 2 times x minus 3 over x plus 4, x minus 3 plus x minus 6, x plus 6 over. These are all the ones that you did, x minus 6, x plus 4. Do you see any cancellations?
X minus 6 and x minus 3 on the left, and yeah.
Okay, so we're left with 2 over x plus 4 plus x plus 6 over x plus 4. What can you do from here?
Combine them.
Why? Why are you allowed to combine them?
The bottom's the same.
Okay, so I'll write the bottom. I want you to tell me what goes in the top, but I want you to simplify it as much as you can.
Uh, two x plus 6.
So that it's good to take an intermediate step here where you actually write them down and then decide what can I combine, because I think you thought that you could combine the 2 and the x, which is why you said 2x, but the 2 actually goes with the 6.
Yeah.
So what does it actually become here? How do you want to revise what you said?
12.
You're
X.
adding
8 plus x.
x plus 8. Good. Okay, let's look at another problem here together. Let's say it's x plus 1 over x times x minus 3 plus 3 over x minus 3. So I've already done the factoring. What is the same or different about the bottoms?
The right So right, x minus 3 is missing the outside x, I think.
Okay. Do you remember us doing a problem like this earlier, a similar one?
Yeah.
How did we make the bottoms the same? What did we do to make it so they were identical?
What was it?
Let's go back and look. Because I want you to see that we've already done one like this. So this
Yeah.
is definitely something that you can do. What did we do here? What's in blue? What do you see?
Missing an x.
Yeah, so we put an X on the top and an X on the bottom. And that's what this problem requires you to do. It requires you put an X on the top and an X on the bottom. So the bottom becomes X times X minus 3. Can you tell me what the top becomes when you add them together?
Wait. Wait, did you combine the bottom?
I did. You keep it the same. The bottom, you keep the bottom. We talked about that for a while here. Keep the bottom. But the top, I'm asking about the top here. What do you do to the top?
Can you combine it? I mean, or
So that's X plus 1 plus 3 times X. Because the X and the 3 are multiplying.
okay.
What does the top become?
Well, did you combine now?
Yes, you combine like terms.
4x plus 1.
4x plus 1. Excellent. All right. Okay, so we're going to stop right there for today.